So far we have found that atoms consist of protons, neutrons and electrons. Furthermore, we know that protons and neutrons are contained within a very small core of the atom called the nucleus, which is between 2 and 15 times 10 to the minus 15 meters in diameter. The electrons are then found outside of the nucleus. Now that we know what an atom is composed of, we can start to investigate differences between atoms. We'll do this by starting with Dalton's atomic theory. Dalton postulated that atoms are indestructible and cannot be broken down further. He also said that all atoms of an element are identical, where an element just represents one type of atom. Different types of atoms, or elements, have different chemical properties. And finally, atoms can combine in whole number ratios to form compounds, which contain two or more different types of element. As we know, 1 is not true, because we have protons, neutrons and electrons within the atom. 4 we'll leave until later. So that gives us 2 and 3. The questions then become, what makes all atoms of the same element the same, and what causes different atom types or elements? The answer is the same for both questions, the number of protons. It is for this reason that we give the value of the number of protons in an atom a special name, the atomic number, and we give it a special symbol, Z. Of course, it also turns out that not all atoms of the same element are necessarily identical. They may have different number of neutrons in the nucleus. When atoms have the same number of protons but different number of neutrons in the nucleus, we get isotopes. A special symbol is given for the total number of protons and neutrons, A, the mass number. We can put all of this information together into one all-encompassing symbol shown here, AZX, where X is the atomic or elemental symbol and the A and Z are as described previously. We can now turn our attention to the elemental symbols as provided by the generic symbol X. A look at the periodic table shows us that there are over 100 elemental symbols utilizing all letters of the alphabet except J and Q. Our shorthand notation for the elemental type incorporates the first letter of the elemental name in English and often a second letter. For example, O is oxygen, OS is osmium, P is phosphorus, PR is praseodymium, PM is promethium, PT is platinum, and so on. Other elements follow the same rules except that their symbol is derived from the Latin name for the element. For example, Fe is iron but comes from ferrum, Pb is lead but comes from the Latin plumbum. And it's important to note that the upper and lower case is important. Capital C, capital O is completely different from capital C, lowercase o. The former is the compound carbon monoxide, the latter is the element cobalt. Now we can put all that together and look at some examples. If we see the following symbol, 6,3Li, we can write that this is the element lithium. Since it's lithium, and we see that the atomic number is 3, then lithium has 3 protons. Since the mass number A is 6, then we can say that the number of neutrons is 3 in the nucleus. For 7,3Li, we can say that we have the element lithium again, but this time we have 4 neutrons in the nucleus. Sorry, slight technical difficulty there. So we have 4 neutrons in the nucleus. So this is another isotope of lithium. When we talk about different isotopes of an element, we state the element and the mass numbers. So 6,3Li is lithium 6. And 7,3Li is lithium 7.